Today we're going to talk about Chapter 4, Section 3, specifically having to do with some integration rules. The first integration rule has to do with when we're adding two integrals. So if we look at this sort of graphically, if I wanted to find the area under the curve from A to B, that would be this shaded area here. And if I added the area under the curve from B to C, that would be the rest of this shaded area here. That means that essentially all we're doing is we're integrating from A to C of this function. This helps us when we're doing geometric integration. So here I'm trying to find the area under the curve from 0 to 3, and I look at that graphically and go, okay, well, starting at 0, that's this shaded area here, and then this area down here as well. So I do the reverse of that rule and say, oh, well, this is just going to be the integral from 0 to 2 of f of x dx plus the integral from 2 to 3 of f of x dx. Which is to say it's just the area of that circle, which we found in yesterday's lecture to be pi, minus, because remember, area below the x-axis is negative, 1/2 the base, which is 1, times the height, which is 2, so it's just pi minus 1. So use that property and your knowledge of geometric integration from yesterday to find the area under the curve of f of x from -5 to 5. So starting here and ending all the way over here. I'll give you a few minutes to compute that area. Alright, so you probably split it up like I did into a series of triangles, rectangles, and that circle. So let's just go left to right using those geometric shapes. So the leftmost triangle has a base of 1 and height of 2, so area of -1 because it's below the x-axis. This has 1, 2, so 1. This has a height of 2 and a width of 2, so this is 4. This triangle has base of 1 and 2, so it's area as positive 1. We already computed the circle as pi. We computed this as negative 1. And this rectangle has height of 2 and width of 2, so this is negative 4. So I add all those things together. So this is equal to negative 1 plus 6 plus pi minus 5. So all in all, we just get this area to be positive pi. The next property concerns when the limits are sort of reversed from what we're normally used to seeing. And what I mean by that is we've been doing everything the integral from a to b. Well, what about when it's the integral from b to a? Or just look down here, we can see that this isn't like the integrals that we have been doing, because the integrals we have been doing, the lower numbers on the bottom and the bigger numbers on the top. So what do I do when it's reversed, when it's sort of like we're integrating, instead of from left to right, we're integrating from right to left? Well, I use this property up here. If I'm trying to integrate from a higher number to a lower number, that's the same thing as the opposite sign of the integral from the lower number to the higher number. So if the integral from 1 to 4 of this quadratic is 39, then the integral from 4 to 1 is just negative 39. And the key here on understanding when to use this property is when I have the higher number on top and the lower number on bottom. Then I'm going to just integrate like regular, but switch the sign. So if I wanted to find the integral of this function from 5 to 2, that would be the same thing as opposite sign, the integral from 2 to 5 of f of x. So we're talking about the area starting at 2 and going all the way to 5, which we've already found to be negative 5. So it's opposite the sign of negative 5. So this is equal to positive 5. The final property is that if I have a constant times a function and I'm trying to integrate that, I can just take that constant and move it out in front of the function. And we've been dealing with this. We did this during u substitution all the time, so it's really nothing new. But if I have a constant times a function, that's the same thing as the constant times the integral of the function. Here is your homework for tonight. You'll probably have enough time in class to get that done. And as with the past couple of days, the answers and my work will be on Edmodo this evening. Have a good day.